Okay, so this lesson is the start of a new unit called trigonometric functions. And the first thing we're going to look at is modeling or looking at what we call periodic behavior. So the success criteria for this section is that hopefully by the end, you'll be able to define and identify what a periodic function is. And secondly, once we see a periodic function, define and determine what the period is, the peak, the trough, the amplitude, and finally the equation of axes of that periodic function. So before we begin looking at some of the details, let's look at some of the observations of this function. First of all, we note that it is a function because we look at sort of like a vertical line test. Only at one point on the line does it cross the vertical line test. So how can we describe this? We could say that one, a lot of things that a lot of kids say is that it looks very wavy, or what I like to say, there's curves. Another thing that we could kind of notice that there's a pattern, there's a repeating pattern that's happening. One of the unique things, now we look at this function compared to maybe some of the other functions we looked at in our course thus far, is that it has a maximum value. In other words, there's a high point in our graph. And in this case, there's more than one. So for example, there's a high point here and a high point here that we could see. While some of the functions we looked at had high values, this one also has a minimum value or a low value. So we haven't really looked at a function or graph so far this year that has both high values and a low value. So this one is unique in that sense. So here we could look at maybe the low points on the graph here. We have one here and one here. And again, because we notice that there's a repeating pattern, those maximum and minimum values also repeat. So let's look at some definitions. So a periodic function by definition is a function where the graph repeats at regular intervals. And this is what we kind of noticed at the top. But more importantly here is that not only does it repeat, but it's repeating at a regular interval. So what that means is the y value show a repetitive pattern when the x value is changed by the same increment. And we can define that increment by the value p. In other words, it's repeating every p values as we go across the x-axis. And therefore, the idea of a periodic function is that when we have f of x plus p, in other words, we have f of x, and we add p to it, add p to x, we're going to get the same y value of f of x. The period is defined as the horizontal length of one cycle. So we haven't defined cycle yet. Cycle is basically one part of the graph where it starts repeating. So for example, we may say that the graph repeats from, let's say, here to roughly around here. So this in itself is one cycle. So the period is how long it takes for that cycle to repeat. So in this case, we can see that the period here would be 3. It repeats every 3 units. A trough comes from English word. If you ever heard of a pig trough or something, that means the bottom of something. So when we talk about troughs, this is the minimum value of the graph. So as we identified before, this graph actually has multiple minimum values. So there's a minimum value there, the minimum value there. And we can see that the minimum value, or the trough, in this case is equal to 1. Likewise, the more obvious terminology is peak. To be honest, I don't know why they choose different terminologies all of a sudden for minimum and maximum. But in terms of periodic functions, we have the term peak. And again, in this graph, we can see the peak happens at several points. And here we can see that the peak, in this case, the value is 5. And notice that because it's periodic, the peak will repeat itself, and so will the trough. I'm actually going to look at the next definition first, equation of axes. Equation of axes is, you can think of it as a halfway point between the maximum and minimum, or a halfway point between our graph. And it's the equation of a horizontal line. So we know that any equation of a horizontal line is y is equal to. So we could look at it visually, and we could say that, well, the halfway point between 1 and 5, so 1 and 5, halfway point between there, we could kind of see it looks like it's right there. So in this case, the equation of axes is y is equal to 3. Okay, so it's actually easier to maybe visually look at it, but we want to look at it algebraically. We could look at the equation of axes is the peak plus the trough divided by 2. So in this case, we have the peak being 5, the trough being 1 divided by 2, and we do get, and we do get 3. So in other words, the equation of axes is y is equal to 3. Why that's important to know is that from that, we could get what we call the amplitude. Now, a lot of confusion happens when we look at periodic functions, is that people think the amplitude is the entire size of the graph, which it isn't. It's actually half the difference between the max and the minimum. Or what I like to describe is really the amplitude can be seen as the distance from the equation of axes to either my peak or my trough. So in this case, my amplitude, and really that's where you define the size. People think of amplitude as size. That's the size of this graph. If you want to think about it that way, here the amplitude is 2. And likewise here, you can say that the amplitude is 2. So there's two ways to determine the amplitude every given equation of axes. You go from the peak to the equation of axes, or you go from the trough to the equation of axes. They should give you the same value because, again, the equation of axes is the middle of our graph. Again, we can do it algebraically. You can think of it as the peak minus trough. So in this case, we have peak is the 5, trough is 1, so 5 minus 1 divided by 2. In this case, we get 4 over 2, which is the amplitude is 2. Okay, so those are some definitions that are going to be really important for us to know and get a grasp on as we continue through the rest of this unit. So let's look at some examples. We can identify the cycle in different ways. Again, if we go from looking for where the pattern is repeating. So in this case, and one common strategy is you want to go from peak to peak or trough to trough. A third way is you go from where the x-intercepts are, where it's crossing the x-axis, go from there to where it crosses again. But we need to be careful because we need to establish the pattern. So for example, if I was going to go from peak to peak on this graph, going from here to here does not define one cycle because that's not where it's starting repeating. So what we need to do is follow the graph. Starting at this peak, we go across, come down. So over here is where that pattern ends, or we could say the cycle ends. And so that could be one cycle here. So that's one way we could identify it. Another way is we could actually use the trough. So in this case, maybe I'm going to use the trough that's over here. And again, this is where it's going to start going up again. So if I follow along, and it's going to go up again right there. So that's, again, one cycle. We could look at the period. And again, no matter how we look at our cycle, the period should always be the same. That's why it's important that we look at it being a regular interval. If it was not regular, then we cannot determine the period at all because it's not common. So in this case, we would go from here to here. We can see, unfortunately, with these graphs, they don't fall exactly on the crosshair, so we're going to have to approximate. But here it looks like the period here could be, that looks like a half from here to there. There's 2, so here the period might be 2.5, and we could do the same thing over here. It starts right there. We go 1, 2, and that looks like a half, and we could get the period being 2.5 there as well. Okay, so that one was a little bit tricky only because the peaks and the troughs were going across, so we had to make sure we identify the proper pattern. For the second example, it looks like another curvy or wavy graph. It looks a little bit easier to do, but unfortunately, again, it's not on crosshairs. So one way we could identify one cycle, again, is maybe from peak to peak, so from here to here. So that's one cycle. Oops. That's one cycle there. We go from trough to trough. So that's from there to there. Or in this case, because their x-axis actually falls on the crosshairs, that might be an easier way to determine the period. So again, I might start, let's say, right here. We need to be careful because at this point over there, that's not where the pattern starts repeating again. Because here we go down, and after this point, we're going up. So that's not the end of the cycle, but again, it's going to be over here. So there's the one cycle over there. And here we could clearly see that the period is 2. Next one, this one is a little bit easier looking at the peaks. So again, one cycle, we could go from peak to peak over there. So that's one cycle there, or we could go from trough to trough. So that's right there to right there. That will be another cycle there. And each of those, we can see that in this example, it's the same, the period is 2. Here's some more examples where we have to define where it's periodic or not. And if it is, then let's get the amplitude and equation of axes along with the period. So for question number 4, this one is not periodic. Although it looks like there is a pattern there, it's not repeating y values. So that's important. We can see that here, the peak never shows up again. So that's the thing with the periodic function, is that the period and the troughs need to be repeating as well. This one, it's a little bit hard to tell because it's not we can't see a lot of the graph. In this case, we could probably only see one cycle. So from there to there, but within there, it looks like it's periodic. So here I sort of helped identify the peak, or sorry, the period. Although I'm going to use the x-axis, that's a little bit more clear. In this case, the scale on the x-axis is every 2. Every line is 2, so that's 6, 8, 10, 12. So here we can see the period is 12. In order to get the amplitude and equation of axes, as simple as it sounds, it's going to be repeating in the rest of this unit. It's just looking for the peak and the trough, or the maximum and the minimum. So in this case, the peak of this graph, the peak is 2, and the trough is -2. So in this case, the equation of axes is really, you can think of it as like an average. So this is going to be 2 plus -2 over 2, and here we're just going to get 0. So that is y is equal to 0 is my equation of axes, and the amplitude is peak minus trough. So here we're going to write the amplitude. Not the best, should have provided more room for this. This is going to be 2 minus -2 over 2, which is 4 over 2, which is 2. Okay. This next one, number 6, again, it's not periodic because, again, the y values are not repeating. Although it looks like it's at regular intervals, something is happening, but the important thing is the y values themselves are not repeating. Likewise for this one, yes, we have consistent peaks, so it looks promising, but our minimums or our troughs are not the same, so therefore it's not periodic. Number 8, this one looks like it's periodic. Again, it's hard to tell because we're not really given more than one cycle, but you can kind of see that the pattern is going to be repeating. And again, I'm going to go from, this one is a little bit tough, looking for crosshairs. So again, I might go from there to there. That's one cycle. And that's, again, every line is 2. So I'm going from -2 to 6. So that gives me a period of 8. And let's look at our peak. The peak, the highest point in this graph, doesn't fall on a crosshair, but we can estimate 2, 4, 5. And the trough, in this case, is -4. So again, our equation of axes is going to be sort of like the average, or add the 2, peak plus trough. So in this case, it's going to be 5 plus a -4 over 2, which gives me 1 over 2. So y is equal to 1/2 is the equation of axes. And eventually we want to get in the habit of, once we calculate the equation of axes, it just sort of roughly sketched that into our graph. So there is y is equal to 1/2. And our amplitude is peak minus trough. So in this case, 5 minus a -4/2, which gives me 9/2, or roughly 4.5. So that's our amplitude. The last question, number 9. Again, it's kind of hard to tell because we're sort of given one cycle and it's a funky pattern here, but this is periodic. We do happen to see the peaks repeating and the troughs repeating at the same value. So in this case, I'm going to use the peak here because it's rather nice. Well, almost on the cross here. Looks like here the period is 2, 4, 6.5, so 7. And the peak in this case is 4. The trough, or the minimum value, is a little bit, so halfway between -4 and -6, so -5. So here, equation of axes is sort of like the average of the two. That's how I like to think of it. So we're going to add them. So 4 plus or minus 5/2, which gives me -1/2. Again, I'm just going to draw that in, maybe somewhere around there. Y is equal to -1/2. And the amplitude is peak minus trough. So it's going to be 4 minus -5/2, which happens to be the same as our previous example of 9/2 or 4.5. Okay, so let's look at the next example where we're given a graph, f of x. It seems like we're given, well, first of all, the question is to determine how many cycles in a graph, and there's how many things we can see repeating. So if we go from here, follow the pattern, and it seems like it ends here and it starts again and it ends over here. So it looks like we have 2 cycles. So what is the period, or what's the length of a cycle? So here we identify it as 1 period, or sorry, 1 cycle. So what's the length of that period? It's going from -2 all the way to 3. So here we can say that the period is 5. We can also go from this point to this point. So that's going from 3 to 8. So again, that's 8. So that's also a distance of 5. Another way we can also look at the period. Again, the definition of a period is any 2 points where it starts repeating. We could go from peak to peak. And again, that distance there will give us 5 as well. Or we go from trough to trough. That will also give us a distance of 5. So there's many ways in looking at a graph determining what the period is, as long as we can see what 1 cycle is. The peak of this graph, so what's the high point? I already circled it, so that's over here, so that's a high point of 4. And the trough is the low point, so I circled over here, and that has the lowest value of -2. So calculate the amplitude. Again, the equation is amplitude is peak minus trough over 2. So in this case, the peak is 4 minus 2/2. In this case, that's 6/2, which is 3. So that's my amplitude. And the equation of axes, and the equation of that is peak plus trough over 2, which is 4 plus a -2/2, which is 2/2, which is 1. So one of the things I always do whenever I get the equation of axes is I like to draw that on my graph. So again, the equation is y is equal to 1. And let me do that in a different color. Let's do that in purple. And so there's my equation of axes. And the nice thing about drawing a graph is that that should be the middle of my graph. In other words, in between my maximum and minimum. And that looks like it is correct. So now we're given some other questions on here. Assuming that this periodic behavior continues, then what is the value of? So this is the beautiful thing about periodic functions, and this is where we really want to start examining things, is that if we're given, want to figure out what f of 12 is. In other words, when x equals 12, what is my y value? In other words, where would it cross the graph if this graph continued? So one of the things that we could do if we wanted to is that we could sort of cut this graph, cut 1 cycle of it, shift it across, and find out where it is. Not so convenient, so let's do it algebraically. So the whole idea of it being a periodic function is that repeating at regular intervals. So in this case, we know that since the period is 5, the y value will repeat at every x value of 5. So in this case, well, we could say that f of 12 is the same thing as f of 12 minus 5. Because why do we want to go subtracting 5? Because it will give us a point that's actually on our graph. So in this case, this is the same thing as f of 7. And we look at f of 7, it happens to be at our trough. So that's just going to be the same thing as going to evaluate to evaluate to negative 2. Likewise, when we look at f of negative 4, again, if we look at our graph over here, choose a different color green. Negative 4 is here. Again, a graph doesn't go there, but because it's periodic, we could know that our x value is going to repeat every 5. Sorry, our y value is going to repeat of every intervals of 5. So this is going to be the same thing as f of minus 4 plus 5, which is f of 1. So where's the graph cross when x is 1? It crosses right there, so that has a y value of 1. Now it gets a little bit more tricky because now we're going to a next value that is really away from what our graph is given. So what we can do here is that we go adding or subtracting multiple periods. So in this case, thankfully, our period here is 5. So we'll go to various multiples of 5 until we get within our graph. So in this case, we can say that this is the same thing of f of 35. In this case, I'm going to go really extreme, and I know that 30 is a multiple of 5. So this, we're saying that f of 35 is the same thing of f of 5. So now if we look at our graph, f of 5 happens to fall on our peak. So f of 5 here falls on our peak, so that we know that f of 5 in this case is 4. Now we're going really extreme to the right, f of 71. So we're going to apply the same strategy here, in that I know that f of 71 is the same thing as 71 minus a multiple of my period. In this case, I'm going to choose 70 because I know that f of 1 is in my graph, and f of 1 I think we did already. Oh, it was the same as f of minus 4. In this case, it's 1. So that's how we could do a question like that.